Hello students, welcome to Physics Bouquet. Today we will discuss second part or last part of the Rayleigh Jeans law derivation. In part 1 we had derived n1 square plus n2 square plus n3 square is equal to 2a nu by c whole square, where nu is the frequency of vibration and n1, n2, n3 represent different sets of modes of vibration. Now, moving further, let me discuss. To explain it, let me discuss the equation n1 square plus n2 square is equal to 2a nu by c whole square. You students, it is well known to you that this is the equation of a circle. This is the equation of a circle whose radius is 2a nu by c, and center is at the origin. n1 minus 0 square plus n2 minus 0 square is equal to 2a nu by c whole square. So in this circle, if we draw n1 along this, take n2 along this and plot a graph. Suppose this is 1, 2, 3, 4, 5, 6. For example, let me take 2a nu by c is equal to 10. So here I will have 10. This is 1, 2, 3 up to 10. Similarly this side 1, 2, 3, 4 like this. Here it will be 10. Now if I draw ordinates and abscissa like this, then we have different sets of n1 and n2. See, for 1, this is 1, 2, 3. So 1, 1 can be a set. Then 1, 2 can be a set. 1, 3 can be a set. But if I take, suppose this is 8 and suppose this is 6. So this is 8, 6. Then I will get 8 square plus 6 square is equal to 10 square. So it lies on the circumference of the circle. But if I take, suppose 3 and 2, this point is 3, 2. So 3 square plus 2 square is not equal to 10 square. It is less than 10 square. So those sets of n1 and n2 which lie inside the circumference are of frequency less than nu, and those which lie on the periphery they belong to frequency nu. Here, for example, 8 and 6, it lie on the circumference. So 8 square plus 6 square. So it corresponds to frequency nu, and those lying inside the circle, they belong to the set which is less than nu. Further, this n1 and n2 are positive integers. n1 is positive, n2 is positive. So all of them will lie in first quadrant, this second quadrant, third quadrant, fourth quadrant. These are not possible because we have already taken n1 and n2 as positive integers. So in this circle, this first quadrant represent the different sets of modes of vibration. So first quadrant of the circle represent different sets of modes of vibration. This is one thing. And second thing, see, each square is a unit square. Its area is unity, its area is unity, its area is unity, its area is unity. So number of squares inside this quadrant is equal to area of this quadrant. See, suppose here total, this is a square, this is a square of unit square, all these are unit squares. Each has area 1. So number of squares in this quadrant is equal to area of this quadrant. And since the number of squares represent the sets of modes of vibration, so the total number of sets of vibration is equal to the area of the quadrant. You are understanding? The number of unit squares inside this quadrant represent the sets of modes of vibration, and that is equal to the area enclosed by this quadrant. Area enclosed by the quadrant, and that is less than frequency nu, less than frequency nu. Similarly, here we have in this equation we have n1, n2 and n3. It is the equation of a sphere. It is the equation of a sphere with center at origin 0, 0, 0, and the radius of the sphere is 2a nu by c. Now if we take n1 along the x-axis, n2 along the y-axis, n3 along the z-axis, then we in this circle, these are unit squares, and the squares will be replaced by, since it is a sphere, three-dimensional image, three-dimensional geometrical figure. In the circle, these are unit squares. So in the sphere, the squares will be replaced by cubes. So instead of squares, there will be cubes, and those number of cubes will give us the sets of modes of vibration, and these will be unit cubes. Like here unit squares, in here we will have unit cubes. So the number of unit cubes in the, here we are taking the number of unit cubes will represent the number of sets of modes of vibrations, and the number of sets of modes of vibration will be equal to the volume enclosed by the octant. Here we are taking quadrant, n1 positive, n2 positive. So in this first quadrant, the first quadrant will represent the frequency nu. frequency less than nu. So similarly here n1, n2 and n3 are positive, all are positive. So the volume enclosed by the first octant, here it is quadrant because we are there are 4 parts. So quadrant, this is a quadrant, this is quadrant, this is quadrant, this is a quadrant. Similarly in sphere in 3 dimension we have, there will be 8 parts and each one will be an octant. So volume of the first octant, will give us the sets of modes of vibrations. Hence see, in case of circle we are getting less than frequency nu by finding out the area of this quadrant. Suppose we are asked to find out the number of squares with less than nu plus d nu, then we will take a circle of radius nu plus d nu. That means it will be replaced by 2a nu plus d nu by c whole square. Then if I will be asked to find the sets of modes of vibrations within frequency range this nu to nu plus d nu, then what I will do? This is 2a nu by c radius and another 2a nu plus d nu by c, this radius, and I will subtract this area from this area, so that I will get the sets of modes of vibration within the range nu and nu plus d. What is the area of the quadrant? 1 by 4 pi r square. Pi r square is the area of the circle, quadrant is 1 by 4 pi r square. So pi r square के जगह 2a nu by c whole square. And for this 1 by 4 pi 2a nu plus d nu by c whole square. If I subtract this from this, then I will get the sets of modes of vibration within the range nu and nu plus d nu. This is for the equation of circle. Similarly, what I have to do to find out the sets of modes of vibration for this equation in the range nu and nu plus d nu, I have to find out the volume of the octant with radius of radius this minus volume of the octant of radius 2a nu by c. But what is the formula for volume of a sphere? 4 by 3 pi r cube. So for an octant it will be 1 by 8. So this is the volume of the octant. So for this volume of the octant 2a nu of radius this, what I will do? 1 by 8 4 by 3 pi r के जगह 2a nu plus d nu by c whole cube 4 by 3 pi r cube minus volume of the octant of radius this 1 by 8 into 4 by 3 pi 2a nu by c whole cube. So this gives the sets of modes of vibrations n1, n2, n3, n1, n2, n3 different sets of modes of vibration will be equal to the volume enclosed by the radii of the sphere with this and this. Now let us take common 1 by 8 4 by 3 pi और क्या कॉमन ले सकते हैं 2a by c का होल क्यूब मतलब 8aq by c क्यूब कॉमन ले जाओ तो ब्रैकेट के अंदर क्या रहेगा न्यू प्लस डी न्यू का होल क्यूब माइनस न्यू क्यूब कुछ कैंसल होने वाला है 8 देन I will get 4 by 3 pi a cube by c cube. Now expand it a plus b whole cube. This is a cube plus b cube plus 3a square b plus 3ab square minus this me q. So nu q cancel out and since d nu is very small this higher powers of d nu can be neglected. Since d nu is a small quantity I can neglect it. So this term becomes 0, this becomes 0. What I will get 3 nu square d nu. So number of sets of modes of vibration will be I a q by c q into 3 nu square d nu. So this 3 cancel out. I get 4 pi a q nu square by c q d nu. But what is a q? AQ is equal to volume of the cube. Volume of the cube. Each side of the cube is A. So A cube is volume of the cube. Let it be represented by capital V. So the number of sets of modes of vibration will be 4 pi nu square by c cube into this v into d nu. So this is the sets of modes of vibration. But our heat radiation is an electromagnetic wave and hence like light it has for each wave since light is an electromagnetic wave and all electromagnetic waves are transverse waves. So for each wave there are two possible states of polarization. For each state of polarization this is this. So for two states of polarization 2 will be multiplied. So the number of sets of modes of vibration will be 8 pi nu square by c cube into v d nu. Now come to our original formula where we had given the formula energy density, it was perhaps equation number 2. Energy density energy density within the frequency range nu and nu plus d nu is equal to average energy of each mode of vibration, that is kT, into the number of sets of modes of vibration in the range nu and nu plus d nu per unit volume. So per unit volume it will be 8 pi nu square by cq d nu. So this is, I have left this v because this is for v volume, number of sets of modes of vibration. Per unit volume it will be divided by v, so v will cancel out, I'll get that. So u nu d nu is equal to, ultimately I will obtain 8 pi nu square by cq into kt d nu. And this is Rayleigh Jeans law in terms of frequency. So sometimes such question is asked to write Rayleigh Jeans law in the form in terms of wavelength. In that case, nu is will be replaced by c by lambda. C is speed of light or speed of heat radiation. So if nu is equal to c lambda, then our d nu is equal to minus c by lambda square d lambda. Now our u lambda d lambda will be equal to 8 pi c square by lambda square by cq into kt into minus c by lambda square d lambda. So this c square cq becomes c, then this c and c cancel out, hence finally we obtain u lambda d lambda is equal to 8 pi lambda square kt 8, this is by lambda square, and this lambda square into lambda square, so 8 pi by lambda 4 into kt d lambda. So u lambda d lambda is equal to 8 pi kt by lambda 4 d lambda. This is the form of Rayleigh Jeans law in terms of wavelength, and this is in terms of the frequency. So this is all about the derivation of Rayleigh Jeans law, and this completes the derivation. Have a good day.